Topic 1.6, Exploring the Pythagorean Theorem. The Pythagorean Theorem is true for right triangles only. It doesn't hold for triangles that are not right triangles. A set of three whole numbers that satisfies the Pythagorean theorem is called a Pythagorean triple. For example, 3, 4, 5 is a Pythagorean triple because 3 squared plus 4 squared is equal to 5 squared. Right? 3 times 3 is 9. 4 times 4 is 16. 9 plus 16 would be 25. And 5 squared is 25. So this is a true statement. When that works, we are dealing with a Pythagorean triple. So if we're given any set of three numbers and we're asked, is this a Pythagorean triple? What we're really being asked is, do these numbers work with the Pythagorean theorem? In other words, can these numbers represent the side lengths of a right triangle? Because we know that the Pythagorean theorem is true for right triangles only. So let's say we're given the numbers 7, 24, and 25. Well, we can use the Pythagorean theorem, plug those values in, and see if they work. If they work, we know that we're dealing with the values of a right triangle, so the lengths of a right triangle. And if they don't work, then we know that we're dealing with a different kind of triangle. Could still be the values of a triangle, but it certainly isn't a right triangle. Okay, so the hypotenuse is always the longest length. So we know that the largest number here is going to be the value of the hypotenuse. And the two smaller numbers, the 7 and the 24, those will be the lengths of the legs. So I'm just going to plug them in accordingly. 7 squared plus 24 squared is equal to 25 squared. And then we can solve this. 7 squared I know is 49. 24 squared, we'll need some calculator assistance, is 576. And 25 squared, 625. Okay, then what you can do is you can add up these two numbers, so 49 plus 576, and see if this is a true statement. 625 is equal to 625. If this is a true statement, like we see it is here, then we know that these values together make a Pythagorean triple, and that they represent the dimensions of a right triangle. Let's have a look at a couple of additional examples. Let's say we're given a set of three numbers and we are asked, is this a Pythagorean triple? In other words, does it work with the Pythagorean theorem? Or are these numbers representative of the side lengths of a right triangle? So we can of course use the Pythagorean theorem to solve this. And if we plug these numbers in and our equation is balanced, then we know that we are dealing with the lengths of a right triangle, and that this is in fact a Pythagorean triple. If it's not, then we are not dealing with a right triangle. Still could, of course, be a triangle, definitely not a right one. Now recall also that the hypotenuse is always the longest side of a right triangle, and that is represented by the letter C. So the other two smaller numbers, they will be A and B. So I'm just going to plug these numbers in to this equation, and we can solve it. See if it's balanced. 16 squared is 256. 30 squared is 900. 34 squared is 1,156. Now if we add up the two squares of the legs, we will actually get 1,156. So this equation is balanced. The two numbers on both sides of the equal sign, they are the same. So it is a balanced equation. That means that these three numbers are in fact a Pythagorean triple. And we could actually sketch a right triangle now with confidence and label the sides, because we know that they are the lengths of a right triangle. How about the next set of numbers? Is that a Pythagorean triple? We can follow the same procedure to determine whether it is or it isn't. So we're just going to plug in those numbers into this equation and see if it is balanced. Remember, the largest number here would be the hypotenuse. So 8 squared plus 10 squared is equal to 12 squared. We'll just put the largest number on the hypotenuse side of the equation. And then we just square these numbers and see if we're dealing with a balanced equation. So 64 plus 100 is equal to 12 squared, which is 144. This would be 164, which is equal to 144. Is that true? That is not a true statement. Okay? That means that this is not a Pythagorean triple. Those numbers do not represent the side lengths of a right triangle, at least. They could very well be the lengths of a triangle, just not a right triangle.